How you all doing? Welcome to another video, and this one is going to be about the, well, let's call it an autopsy of this Parkside angle grinder. So I've kind of taken it apart already. I didn't think this was going to be salvageable, but looking at it now, I'm sort of thinking it might be possible to save it. But basically, you've got a big head like this, sits in a motor's housed in this piece of plastic here, this moulding. So I've just taken apart the handle, which just comes apart with a few screws. So that's the handle. Look at it backwards there. So you've got a switch here on the side, and you've got it's actually got a speed controller and a switch. Basically, that's all that's on this side. Not much to it really when you look at it. And got a small circuit board here. And then you've got the brush holders here either side. So, I mean, these tools, they're basically disposable. Anybody who thinks that these are going to be something that you're going to keep for 20 years is just only kidding themselves. So, I just wanted to try and have a look at this thing. The failure mode on it was that it just stopped working and let off a big spark. So, I had initially thought it was going to be something like the armature in the motor, or else that the actual brushes were sparking. But taking a closer look at this, and let's take a closer look. I'll get you zoomed in here. So if you have a look in here, you can see the wiring on this is pretty nasty in places. It is, as you can see, there's little places here where it looks like it's just been caught, and where the wiring's been rubbing. So that in itself is not very reassuring. So I'll just switch now to another view just to try and show you the inside of the angle grinder. It's going to be hard to show you guys in here, but there's basically, if you have a look at what's going on here, there's 4 wires that go in there, and when I inspected one of them, it's going to be extremely difficult to show this. Actually, I might try and light up the inside of it. Let me see if that'll work. Will that work? If you can see just in there, I don't know if you can see it, but it's quite hard to see just in here. There's a wire in there that has shorted itself out against one of the brush holders. So it looks like the wire, just through mechanical stress or whatever, it has just rubbed through and it has touched one of the brush holders on the one that's on this side here. So this guy here, and that's just shorted the whole thing out, and there's actually black marks in there. So what do we do? So I mean, this thing was like $20. It's not going to be, it's barely worth repairing, but I'm just going to do it for the sake of doing it, because I've got nothing really else to do this evening. But you can really see the build quality here of these things. They're just made to just the absolute cheapest spec that you can make. Have a look at that wire there. That was pressed in. If you have a look, there's a little fork in here where that wire sits into. And as you can see, there's been wear on that wire where it's just sat down in there, and that's not what you want to see. You don't want to see electrical wires with places where they're rubbed through, or where the quality of the wire is not good enough that you can actually and will rub through, that the coating isn't thick enough. So there's quite a few places where, the wiring looks a bit sketchy in this thing. So to get this out, we're going to have to cut the 2 wires that come from the handle section. We're going to have to cut these 2. Slide this out, and then we'll get a proper look at it then and see what to do next. Right, so we had to cut 2 wires to get this off. So we had to cut which one actually was it? Yeah, this guy here. We had to cut this guy here, and we had to cut this guy here, but we can solder those back on pretty easy. And then we had to just take the spades off the brushes as well, just to get those off. So there's 2 wires going to the brushes, and then 2 wires going to the back of the unit. So you can see here the problem now, and this is what I was talking about earlier in the video, how nasty this is. So this is the wire in here that's completely eaten through, as you can see, just through mechanical stress probably and vibration against the actual body of the unit. You can see where it's completely chewed through. So we're going to see if we can try and salvage this. as you can see here, it wraps around this post here as well. So this is looking really nasty. I'm not sure whether this is salvageable or not. And I'm looking up here too. I can see some burn marks up here, which I don't like the look of at all. See those burn marks? I don't like the look of those. Could it have shorted and just this wire was turned into a fuse and it blew because it started to draw too much current? That's also a possibility. Just unwrap this guy here. Yeah, that's looking really nasty, guys. It's weird because I think this arcing here is just because this is plastic. This piece is plastic, and I think with the black marks here were just where the wire was arcing and starting to burn this. It doesn't look like the windings themselves are actually damaged. No, I think we'll have a go at trying to salvage this. We'll see what we can do. As I say, it's hardly worth saving this unit, but because it's such a simple thing just to have a go at, we'll try it and see. Yeah, the burn marks further along the wire just don't seem to be as a direct result of a short in there. It seems to be just like collateral from wherever this was arcing like mad. It must have been arcing like crazy. Right, so let's cut this wire and just see how clean it is. So I'll just take my snips and cut this, and I'll be back in a second. Right, so I've just cut back the sheathing on the wire, and the wire itself looks okay. It looks pretty clean. It looks like with a bit of flux, that will be solderable. So I think we'll have a go with this. Right, so I'll have to just get a bit of wire now. Cut the other end of the wire, obviously, where it's damaged, and we will just replace that whole piece. So we'll replace from here, going right through back to where that switch is. So obviously this is pretty high current. Well, actually, is it? Well, it's 1200 watts, so it's not stupidly high load, but we'll have to just make sure that we get a wire here that matches this in terms of its girth because of the amount of amperage going through it. So let's get some wiring and let's give this a go. Well, there we go, folks. We've done the repair here. We've just soldered in another wire and we've added some heat shrink onto that. So I've actually done 2 layers of heat shrink. And what I'm going to do next is I'm going to wrap it in this insulating tape here just to give us a little bit more insurance, just against the same thing happening before where it was rubbed. It had obviously rubbed against the body of the tool. Vibration had caused the cabling to wear through. And then it actually shorted to the post where the brushes sit down into. So to stop that, we're going to wrap it we'll probably wrap it right the way up just to avoid the repeat of that happening. So we'll do that. So there we go. We've just wrapped that wire now in insulating tape, which will give it a bit more insurance against rubbing through. Hopefully it won't do it again. And that'll give it a bit more. I mean, it's got 2 layers now of heat shrink and the insulating tape on there, pretty good in 2 layers as well. So that should be good enough. So next job then is we have to resolder the 2 wires back onto the other end of the machine now, back into the handle side of the machine. So that guy had to cut, and this is a new wire that we've put in. So we'll get that soldered on, and then it'll be the moment of truth. We'll check out to see if this has actually worked or not. Right, so we've put the rotor part of the motor back in again and fed the wires back out the back here. That was actually pretty fiddly. There's 4 wires that go with it, and then you have to feed them through the holes in the back of this. And then I've just stripped the 2 wires that we had to cut earlier, and I've just soldered the first one, and I'm about to solder the second one. But this thing just fundamentally does have a design flaw. The way that the cables are routed in there, they're far too close to the rotor as it's spinning and where the brush is actually contacted. So in my mind, this thing, it's just fundamentally built with a flaw in it. So I mean, we're going to fix this, but I don't expect it to last very long because I expect it probably to burn out again. I'll try and give you a look of what's actually inside here in a second. I'll show you the way that the cables are actually routed and just show you the design flaw in this machine. Right, let's get this soldered and we'll put it back together. Right, so we've got it back together again. We've got it soldered up and we've replaced that wire in there that was burnt out. But as you can see, this thing just has a fundamental design flaw. If you can see down in there, see where the black insulating tape is in the wire? Look how close that is to where the rotor will be spinning. And that's the way it was built from the factory too, guys. I'm just kind of replacing where it came from. I've tried as best as I can to route that cable away from where the rotor will be, but at the end of the day, it's just designed wrong. There should be some sort of a stop or a stay or something in there to redirect that cable away from where it is right now. But we're going to throw this back together, see did we fix it, and I don't know how long this is going to last. I mean, it could well burn through it again, but I mean, if it lasts another 2 or 3 years, then fair enough, it's been worth our while. But yeah, don't buy one of these, they're just junk. Just buy something else. Well, it's the moment of truth. We have to check if this thing's working or not. So I've put it all back together again. It was quite dusty, so I gave it a quick hoover inside as well, just to see where it was at. It does have the variable power, or variable speed as I should say. So let's give it a test here. Yeah, it seems to be working again, so at least we fixed it. For how long? Who knows? This thing is built very much to a spec, so... Yeah, so on full throttle there, it looks like it's sparking. So hopefully that might be just the fact that we've put new brushes into it. We'll see how that goes, but yeah, the lower speeds it seems to be okay. Let's try it in between. Let's try it in here just to see what it's like. Yeah, it's not quite as bad. So I think it can be ran at least at low speed, but or medium speed, I should say. And we'll see how long it lasts. Maybe with that sparking, maybe there is a bit of a short in there. Or there's something still not right with it. But yeah, these things are very much built to spec. I mean, what do you expect for 20 quid? So I mean, I've gone out and bought a Metabo angle grinder now to replace this, which is about $70. So you're chatting like 3.5 times the price of this. So I mean, if you're only going to use something handful of times, these are fine. If you're talking about any sort of heavy duty use, it's a big no for me, just because of that design flaw with the way that the cables are routed there. So yeah, it's the Parkside PWS 125 D3, about 3 years old, and yeah, not so good. That's the specs in it there. 1200 watts, so it has plenty of power. It's good that way, but nah. Reliability wise, if you're doing a job and you need a tool that's going to last, don't buy this.